So today we're going to talk about different kinds of reflections and rotations problems than what we've done so far. We're going to be reflecting across a non-horizontal or vertical line, so a diagonal line, and we're also going to be rotating around a center that is not the origin. So this is the first example that I want to look at. So we're going to take the point 64, so that would be your A point, and we want to reflect it across the line y equals negative 3x plus 1. So let me kind of draw you a picture to show you what's happening with this. Okay, so the point 64 is there, and then the line y equals negative 3x plus 1. 1, 2, 3 over 1 gives us this line right here. So we want to take this point 64 and reflect it across that blue line, y equals negative 3x plus 1. So what happens is that this distance from the point to that line has to be the same as what you reflect across the other side. Those have to be congruent. And then that line that you are counting those distances for has to be perpendicular to the reflection line. So you end up getting this point somewhere over here after you do that reflection, but it just takes a little bit of work to see where that point would be. So the first thing is that we have to find the equation of that gray line that I drew, that perpendicular line. So that's the first thing. So we're finding that equation of the gray line in that picture. And then you have to find the intersection points. You're going to solve a system between the gray line and the blue line. So you're going to solve that system created by those two lines. And then we're going to find the other endpoint of this line segment that we drew with this gray line. So you have A is here, this is where A prime would be, and then this was your midpoint where the blue line was going perpendicular. So we have this endpoint. We found the midpoint in step 2, and now we want to find the other endpoint. So we're going to look at that on the next slide. Okay, so step 1 was to find the perpendicular line. So we start out with y equals negative 3x plus 1. My slope in this line is negative 3. If I want a perpendicular slope, that will become the opposite reciprocal. So it flips, so it becomes 1 over 3, and the sign changes. So my perpendicular slope is 1/3. And then from the point 64, I get an x value that's 6, and I get a y value that is 4. So we're going to use those three things, our slope and then our x and y, to find the equation of the line. So using y equals mx plus b, our y value is 4, our slope is 1/3, our x value is 6, plus b. So 4 equals 2 plus b, so b equals 2. So y equals, my slope was 1/3, x, and then our b is plus 2. So that was the first step. We found the equation of a line that's perpendicular to the original and then goes through the point 64. So now the second step was to figure out where the lines intersect. So where does negative 3x plus 1 intersect with y equals 1/3 x plus 2? So to figure that out, you're going to solve a system, because the intersection point of two lines is the answer to a system of equations. And I'm actually going to use substitution here because I know that the y value I can substitute in for y, and then I can solve that system. So 1/3 x is plus 2 is equal to negative 3x plus 1. So I'm going to multiply everything by 3 to clear the fraction. Make sure you multiply everything. So that becomes x plus 6 is equal to negative 9x plus 3. So when I add 9x, I get 10x is equal to, when I subtract 6, I have negative 3. So x equals negative 3 over 10. And then to find y, I'll plug x back in. You can use either equation. So if I use y equals negative 3x plus 1, then I can plug in my x value. So y equals negative 3 times negative 3 over 10 plus 1. So y equals, I get positive 9 over 10, and then I'm going to change my 1 to a 10 over 10 to be able to add my fractions. So y equals, that'll become 19 over 10. So that's the coordinate that those two lines will meet at. So that's the answer to the system, the solution to the system. And that's our step 2. So our third step was to find the other endpoint. So let me draw you a picture, show you what's happening. We had 6, 4, and then we found where the two lines intersected, which was at that coordinate negative 3 over 10, comma 19 over 10. So this is an endpoint, so this would be x1, y1. This is a midpoint, xm, ym. And this is our x2, y2. This is our other endpoint. So we're going to use the midpoint formula. Xm, comma ym is going to equal x1 plus x2 divided by 2, comma y1 plus y2 divided by 2, and plug our values in that we have so far. So I have negative 3 over 10, comma 19 over 10 has to equal 6 plus x2 over 2, comma 4 plus y2 over 2. So this is going to allow us to set up two different equations. Our y value and our x values have to be equal to their matching parts. So our x has to be equal to our x, and our y has to be equal to our y. So that's going to give us two different equations to set up. So we have negative 3 over 10 is equal to 6 plus x2 over 2. This is actually now a proportion, so you can just cross multiply, making sure that you put parentheses around that and distribute. So you have negative 6 is equal to, that becomes 60 plus 10x. So subtract 60 and I have negative 66 equals 10x. And x equals negative 66 over 10, which can reduce to negative 33 over 5. So that's our x value. Now we're going to set up our y equation. So we have 19 over 10 has to equal 4 plus y2 over 2. Now once again, you can cross multiply. Make sure you have parentheses around the top. So you get 38 is equal to 40 plus 10y. So when I subtract 40, I get negative 2 is equal to 10y. So y equals negative 2 over 10, which can simplify to negative 1 over 5. So that would be our final answer. So when you take the point 6, 4 and you reflect across the line y equals negative 3x plus 1, if you call this your original point A, our final point A prime is at negative 33 over 5, comma negative 1 over 5. Okay, so our next example, we're rotating 90 degrees counterclockwise. We're taking the point 2, 1, so that's our A point, and we're going to reflect around a different point now. Usually it said 0, 0, but this time we're going to reflect around the point negative 1, comma 2. So this is our center of rotation. So let's plot our original point, 2, 1. So that's our A point. And then our center of rotation is at negative 1, 2. So that's our center of rotation. Now, how this is going to work is you're going to treat that center of rotation now as your origin. So we're going to draw an X and Y axis going through that point. So that would be your Y and that would be your X. And then we're going to do our rotation. So we're going 90 degrees counterclockwise. I'm going to take my picture and go a quarter turn to the left. So after I rotate my picture, it looks like this. So I'm treating this point as my 0, 0. So if that's my 0, 0 point, I want to write down the points for my A. So I will be going over 1, up 1, 2, 3. So I'm at 1, 3. So now I'm going to take my picture and rotate it back. So now that I rotate my picture back, this will be my y-axis and this is my x-axis. I'm going to plot that point 1, 3. Once again, acting as though this is my 0, 0. So I'm going to go over 1, up 1, 2, 3. And that's where my final A prime point will be. But when we write those coordinates, we want to take those axes away that we are using and write the coordinates down based on your actual graph. So that would be at 0, 5. So that is your final answer for rotating the point 2, 1, 90 degrees around negative 1, comma 2. Okay, so the last problem we're going to look at, a composition of a reflection and a rotation. So we're starting out with the point negative 1, negative 2. So that's your A point if you want to label it a letter. So negative 1, negative 2 is A. So I'm going to reflect across the line x equals 1. This is the line x equals 1. So my point is 2 units away, so I'm going to go 2 on the other side, and that's going to be A prime. Now the second thing in our composition is rotating 270 degrees around the point 2, 3. So I'm going to erase my reflection line because you don't need that anymore. And plot my center. So 2, 3 is the center of rotation. And then make a axis, x and y axis at the center. So this would be your y and this is your x. And I'm going to go 270 degrees counterclockwise. So I'm going to do 3 quarter turns to the left. Okay, so now that we rotated 270 degrees counterclockwise, we're acting as though this is our y-axis and this is our x-axis. So I want to write down what my coordinates are of our A prime point. So acting as though this is 0, 0, this will be 1, 2, 3, 4, 5. So I'm at negative 5, and then down 1, so that would be a negative 1. So now that I have that coordinate, I'm going to rotate my picture back to how it should be. And now once again, acting as though this is 0, 0, I'm going to plot that point. 1, 2, 3, 4, 5. So I'm at negative 5, and then go down 1. So that would be our A double prime. And now to write your final answer, you can take away that axis that we drew because we need to write the coordinates based on your actual graph. So this point is at -1, 2, 3, +2. So that is your final answer.